All right, this is a simple test I'm going to use to demonstrate the usefulness of wearing a glove versus not wearing a glove when working with live electrical components. Now, anyone who works with electricity knows there are specific gloves that are designed to be voltage rated to protect you in the event you should come in contact with a live energized circuit or component. These are not those gloves. These are gloves that you may have in the back of your truck. These are gloves you may have just laying around in your garage, or you may be able to borrow. This is not recommended. It's probably not safe, but we're going to try it out anyway just to see what happens. This is the circuit that I've built. Basically, we have a simple leg coming in, 120, 20 amps. It's going to go to a break at which I'm going to insert a chunk of hot dog right there, and I'll stick that in the glove. And then that's going to come out. It's going to go to a couple of lights and a heat gun. That's just what I had lying around to get some juice going through it. So it's going to simulate a live circuit that you may come in contact on the load side of your house or your garage. Again, this isn't recommended, but let's just see what's going to happen versus wearing no gloves at all and wearing just something made in China, picked up at Lowe's or Home Depot, or just laying around. Let's give it a shot. Let's see what happens here. Now we'll start with my personal favorite setup that I've worn a few times. Again, not recommended, but something that I've done. And that's the setup right here. This is just a basic rubber glove I'm going to use as my dielectric. And then the leather glove simply protects the rubber glove. It's not really going to provide much of any protection. And you know, let's start out. Let's just see the circuit. Let's make sure it's working. Hopefully you can get an idea of what we got going on here. So as you can see, we've got about 122 volts. And we're going to pull about 12.5 amps. About 1,500 watts. That's our ballpark. That's about what we figured out there. We see that that does work. So I'm going to turn that back off. So we know that works. So these are our hot dogs. We're going to save that guy for last. Let's start out with my favorite here. I feel like this is pretty safe. I feel like this is going to provide a lot of resistance. Now I don't know if you can see the hot dog down in there. I've got a little hot dog stuck in the finger. I hope you can see that. I'm going to stick my probe in the hot dog. And that should fill out the glove. That should make it nice and full, stretched out just a little bit. As if you know you had your finger in there. I'm going to go ahead and stick this in my leather glove. So this is a lot of resistance. I doubt very seriously any voltage or current is going to make it through here. It only takes about 20 milliamps across your heart to kill you. So that's really nothing. That's really not very much. That's going to be pretty easy to do. Alright, so I don't know if you can see that there. There's my hot dog inside my rubber glove, inside my leather glove. Let's fire this up and let's see what would happen if I were to touch a live circuit with this setup right here. Let's see if we can get any voltage to go through. I'm going to turn on amperage actually. Now I'm not getting anything to go through that. I'm pushing down on that kind of hard. I've got to be careful here. I am messing with live power, so we don't want to be too dangerous here any more than we have to be just for the fun of it. So I feel pretty confident I could grab a live circuit, although not recommended, and not get a shock. But let's try a few other things. Let's say you didn't have the leather gloves. Let's say you just had these garden gloves here. These are meant for, I don't know, working with just your basic tools. Nothing special. Let's energize our circuit. Let's put it on current. Now even still, there's enough dielectric in this non-voltage rated glove to prevent any current from passing through. Now there is a breakdown to every material, so at a higher voltage this could pass some current through and give you a shot. Again, not recommended, but in a pinch, it's absolutely better than nothing. Unquestionably better than nothing. Again, let's pull this out here. Let's discard that guy. We're going to stick this in here just to show you what it would look like had voltage gone through, had those gloves not been there, had you grabbed that circuit without any gloves at all. This is basically what you would get to expect. Again, we're going to put this on current. Now that would be your finger right there. Now, as you can see, we're getting about 140 milliamps of current going through. And, ooh, there we go. 500 milliamps. Far more than enough to kill you. Anyone who's ever worked in the medical industry or the first responder industry knows what I'm smelling right now. It does not smell like burnt hot dog. It's a very unique and undesirable smell. Clearly, wearing no gloves at all, you're going to get a burn. So while these are made in China gloves, these are meant for working in dirt, these are not voltage rated gloves, these are not safety gloves. They're going to provide enough resistance in an emergency situation or an unideal situation to protect you. Let's try out this gardener's glove here. Let's see if we can get anything to go through it. And let me see if I can get my probe to stick my hot dog in there. I don't think we're going to get anything through this glove either. Again, not what it's designed for, but it's going to provide enough resistance, I suspect, to prevent any current. See, there we go. Just again, I can poke on that kind of hard, and I'm just not getting anything to go through. I wouldn't do it. I would turn off every circuit I work on every time if it's a possibility. Even if it's a low voltage circuit, I'm going to turn it off if I have that option, because there's no point in taking that chance. Let's go one step further. Let's try a black nitrile glove. I don't even know what you'd use these for. I use these for working on my truck. If I'm, changing the brake pads or something, I just don't want to get greasy. If I'm working on my bicycle, if I'm working on my mountain bike, I'm going to put some of these on. I would never trust this to prevent any current. Well, let's try it out. It's obviously got to have some dielectric properties. It is a nitrile style product. Let's see if we get any current to go through that. Again, 120 volts AC. It's got about 20 amps behind it. It is to a breaker, so nothing special. But it is not allowing current through to our simulated finger. As you can see, nothing is passing through that glove, as thin as it is. That really surprised me. I would never try that. That's super dangerous. It does seem to work. Let's put a tear in it though. Let's see if we can, again, just to show you. All right, so there's our tear. Now let's see what would happen if you were wearing these and you accidentally tore your glove. Again, you're getting 300, 500 milliamps, 600 milliamps there. That's, again, more than enough to kill you. It's definitely going to burn you. Even if it doesn't burn you, even if it happens so quick, it's going to be enough of a startle. You could fall off a ladder if you're on one. You could, bump into somebody else who's working around you. You could definitely get hurt in a dozen other ways. Again, this is the circuit, 120 volts. It's a 20 amp circuit. Definitely some power there. So it shows you, if you've got the option, turn the power off. Definitely just work on that circuit. But if you have to work on a live circuit, the very least you can do is wear some gloves. Don't be foolish. You know, it's not worth taking that chance, even if it's just a minor burn. Hey man, you got to keep working. So that's pretty cool. We'll have to try something else next time.